Hello, my name is Andy Schweitzer, and this is a video on a review for reactions for general chemistry. I'm going to move along quickly here. Grab our pen. First things first, it says translate the name into symbols, indicate the type of reaction, predict possible products, balance equation if necessary. So aluminum acetate would be Al. Acetate is C2H3O2 parentheses 3. Sodium metal is Na, no charge, it's plain old metal. This is a single replacement reaction where metal will exchange with metal, and we have to check our activity series to see if this will work. And shows here that sodium is above aluminum, so that will work. In this case, it is going to be sodium acetate +1 -1, so my charge balance is good, and aluminum's all by itself. Balance it, three acetates, 3 sodiums, and 3 sodiums. Number 2, hydrogen gas plus oxygen gas yields water. I would also accept H2O2 as a potential product. Either way, we have a combination reaction or a synthesis reaction. Balance it. We got 2 oxygens, so 2 here, 4 hydrogens, 2 there. Cobalt sulfide, COS. You need to look at the charge above cobalt. It's +2. It's -2. Nickel is also +2, and chloride is -1. So charge balance, and I will get, in this case, double solubility reaction. This cation with that anion, cobalt sulfide, charges will not change. +2, -2. So I need cobalt chloride, so let's erase that here. Let's just put a C here. Cobalt chloride, which is -1, and then the 2 goes here, so make sure that is a -1 here, and then I need a solubility on that guy in a moment, and then I'll do nickel sulfide, and that is going to be +2, -2, and we'll need a solubility on that guy. So any solubility reactions, you have to check your solubility chart. Chlorides and sulfides. Let's see here. So the chloride I'm looking for is right here, and looking for cobalt. Don't see that one there. Again, I'm looking for cobalt chloride, so that's an aqueous. And then the sulfide is nickel sulfide. Here's the sulfide down here, generally insoluble, and nickel's not there. There are exceptions, so it's also going to be this is going to be insoluble for solid, and this is a good reaction. Just go ahead and balance it. 2 chlorides, looks like it very well could be balanced already. 1 nickel, 1 sulfur, 1 sulfur. Yeah, it's balanced. Alright, next one, ammonium silicate. Ammonium is NH4, silicate, SiO3. It's a -2 charge, +1, parentheses, and then 2. Plus potassium phosphate, PO4, -3, +1, 3 goes there. And we're going to do a solubility, potassium and silicate. Potassium silicate, and these are only potential products. I charge balanced already, need a solubility, plus we have ammonium silicate, SiO3, and the silicate, I'll back it up here a second. I'll erase that. Silicate, I grabbed the wrong one again, so I'll just put that in there. And it's going to be ammonium phosphate, PO4 plus 1 minus 3, and the 3 goes right here. Doing my solubility, go to the quick check first, and you'll see that both potassium and ammonium are located in our quick check for solubility. Therefore, this one having potassium is AQ, and this one having ammonium is AQ. This, therefore, is a no reaction. Barium and lead nitrate, BaCl2. Now, there is more than one version of lead, and I should have a parentheses in here indicating the type. So you can just pick one. I'm going to go lead 2, PbNO3, plus 2 minus 1. Charge balance that thing here, and grab my pen here. Charge balance, parentheses, and 2. We're going to get lead and chloride, PbCl2. Again, charges do not change, so that's why the 2 is here. And then barium nitrate, BaNO3, parentheses 2. This is a plus 2 minus 1. That's why that 2 is there. Plus 2 minus 1. Alright, so in this case, because of the nitrate, this will be an AQ, always soluble. I do need to check for barium chloride, so you're looking for chloride in here. Chlorides are generally soluble except for lead. Well, lead chloride is, no, there it is. So it is going to be insoluble solid. And put an S there. Balance it. 2 looks like it is already balanced. Alright, sodium metal, Na, plus chlorine gas. Simply a combination or synthesis reaction. Put the two together, and we get NaCl plus 1 minus 1, so NaCl. 2 chlorines, balancing for 2 chlorines, 2 sodiums, 2 sodiums. We have lead 2 nitrate, so PbNO3 2. Now this particular reaction gives the entire reaction. All you have to do is, it's a decomposition reaction, and we just need to write it out and balance it. Pb should be the same exact lead oxide plus 2 minus 2 plus NO2 nitrogen dioxide plus oxygen gas. At this point, you just balance it and move on. Next one, magnesium metal plus sulfuric acid H2SO4 yields. Okay, so metal will replace metal, and it's going to be magnesium sulfate, and then plus 2 minus 2, so that's good to go. But the hydrogen gas is all by itself. Hydrogen's a super 7, so we have to put a 2 here. That's the elemental form of hydrogen. Do the check to make sure magnesium can replace hydrogen on the activity series. You see hydrogen located right here, and magnesium is much higher, so definitely a go on that. Dropping down, we're almost finished. Ethane, which is C2H6. You should actually know ethane. C2H6 plus oxygen gas yields carbon dioxide and water. You should also know the products of a combustion reaction. Simply balancing carbons, hydrogens, and oxygens. So 2 carbons, 2 carbons, 6 hydrogens, 6 hydrogens. I got 3 plus another 2 times 2 is 4, so there's 7. Cannot get 7 oxygens here, so we'll double everything to 2. And this goes 2 times 4, so we'll go 4 here. And this goes to a 6. 6 plus another 8, 14, put a 7 right here. Chromium chloride, so Cr, Cl, and you need to look up the chart of chromium and multiple charges. I'm going to go with a plus 3, and then put a 3 here, minus 1, and then gold sulfide is AU, and then sulfide. Again, gold does have multiple charges as well. I'm going to go plus 3, minus 2, 3 there, 2 here. Alright, and then you simply need to rearrange your solubility options. Let's go chromium sulfide. This would be a 3 and a 2, and then my gold, we'll go the chloride, and then we'll go 3 here. Plus 3 minus 1, plus 2 minus 2, plus 3 minus 2. Alright, check for solubilities, sulfides, and chlorides. Solubility, so chlorides are generally soluble except for silver, and I don't see gold on there, so we're going to go with an AQ on the chloride, AQ, and sulfide, and sulfides are generally insoluble. The exceptions are just our main soluble compounds, and then these two, magnesium, calcium, and we have chromium, which is not going to be it, so S for solid. Balancing here should work out relatively easily. 3 chlorides, 1 gold, and so I need 2 golds over here, 2 golds, 6 chlorides, so put a 2 here, 2 chromiums, and 2 chromiums, and we are done. Main issues on this test are twofold. One is charge balancing. That is something that many points will be lost on charge balancing. Sure, you write your charges above and make sure your charge balance. And the other thing that makes helps kids lose points is that these individual items coming in pairs. Now there's 7 of them, 7 diatomic atoms. If you avoid these 2 mistakes, you will be ahead of everybody else. Hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. You will lose points on these if you don't indicate them as being diatomic. 2 things to kind of focus on. Thank you.